Hey guys, this maze puzzle seems simple and wicked fun. If you start in the top left corner of the maze and finish in the bottom right, how many different routes are there for you to get through the maze? The restrictions are that you can only move horizontally and vertically through the maze, and you cannot revisit a square during a route. Let's innovatively call this the maze puzzle, from the UKMT's maths challenge aimed at high school students in the UK. Before we start an animated solution, grab a pen and paper and pause me right now. You're going to want to try this one yourself. 3, 2, 1. Let's get cracking with a solution. Let's push our restrictions to the top and first label our maze so we can identify the squares more easily. It's really up to you. I'm going to use letters for the rows and numbers for the columns. Our puzzle, therefore, is to find the number of different paths to get from the top left, A1, to the bottom right, D4. We need to make sure we count all of the paths and don't double count them either. So let's systematically begin from the start by pretending to traverse through the maze ourselves. From A1, we can either move horizontally to get to A2 or vertically downwards to B1. These are the only two options for our first move. Interestingly, thanks to the extra dividers, for our second move, the only square we can move to would be B2, regardless of what we moved on our first. We would either come down from A2 or to the right from B1. This means every possible route to get to the finish would have to pass through B2. It's a non-negotiable square. Since we've worked from the front, let's see if we can repeat this logic from the back of the grid. From D4, every route must pass through C4, as it's the only square that can access it. We could stop here, but thanks to our dividers again, the only way to reach C4 would be to get to C3 first. So every possible route must pass through C3. C3 is a non-negotiable square. From C3 to D4, our route is predefined and we don't have any options. So finding the number of different paths to D4 is the same as searching for the number of different paths to C3. We've shortened our search from the back. Let's see if we can shorten our search from the front based on what we've already found out. We've worked out before that every valid path must pass through B2. One way we could do this is to go to the right and then travel down. The other way would be to travel down first and then go to the right. We have two different options. This means if we just count the number of different paths between B2 and C3, our two red squares, we can double our value to account for the two different ways we could choose to get to B2 in the first place. All that's left to do is to count the number of different ways we can reach C3 from B2, our two red squares. From B2, our two options would be to go to B3 and C2. We could go to A2 or B1, upwards or to the left of our square, but this would involve revisiting a square at some point to pass through C3, so this won't be possible. Focusing on just the routes from C2, the most direct path to get to C3 would just be to travel one square to the right. This is one possible path. Another possible path would be to travel downwards one and approach C3 from the bottom, like so. A second path. Also, we could choose to go to the left and approach C3 from the bottom, pretty much like the second path. This is a third path, making three possible routes from C2. We've explored every possible square and the different ways we can approach C3, so we can be confident we've counted them all and move on to look at B3. From B3, the most obvious path to get to C3 by inspection would be to simply move down one square. This makes four possible routes. We could also move to any of the other squares in a series of moves, highlighted in yellow, but due to our dividers we would have to revisit our B3 square at some point, as this is the only way to approach our goal of C3 from the quadrant of the maze. As a result, any moves here are not allowed by the rules of the maze. Altogether, we've explored every possible route from B2 to C3, giving four different routes. Since our ultimate goal is to find the number of different paths between A1 and D4, we can multiply 4 by 2, giving 8. 8 routes is the final answer. I hope you enjoyed the systematic breaking down of the maze problem, solving each smaller, easier part individually and bubbling them back up into the final answer. Let me know in the comments how you got on with the maze puzzle. Thanks for watching Beat the Calculator. See you next time for more logic and maths fun.